Welcome to the Extinction Level Event Podcast, Apocalypse Edition. I am your host, the Barrelman. So today our main topic is going to be the Earth's magnetosphere. We are also going to have a few other little tidbits to talk about. So I am recording a lot of these in a kind of a short period of time because I just did my first day of work. And this is the weekend. I have the weekends off. But I did my first day of work on Friday. Monday is a holiday, so I will be going to full-time work on Tuesday. So I won't have quite as much time to do these. So I'm definitely, stocking up now. Having said that, let's talk really quick about a little thing that I've been noticing on some of the podcasts some of the YouTubes that I've been watching talking about evolution. And looking up the definitions, it has definitely changed since when I was growing up. Because when I was growing up, it was about becoming a more perfect form of something. Slowly become the perfect shark, slowly become the perfect rhino, slowly become the perfect giraffe, whatever. Evolution wasn't simply change, it was change to be a better, more improved, and more perfected form of whatever it is. That's not really the way it works. So I was like, I don't really believe that. I don't believe there's any perfect form of anything that anything is trying to reach and slowly try to achieve that thing. It's all about adaptation. You adapt to things. A great white shark is no more perfect than a hammerhead shark. Is no more perfect than an anteater. None of these things are any more perfect from each other. They're all suitably adapted to the thing that they're doing. The environment, prey, a lot of things change. So as things change, you have to adapt. And adaptation isn't a voluntary thing. It just happens through genetic drift, alleles. There's a lot of little things. But basically, mutation. Your body, your genetics change. Through procreation and heredity. Yeah. So yeah, slowly you will adapt, or you will not, because there's plenty of people who do not adapt. But evolution also comes with de-evolution, and that I think is where the trouble in the definition is between something becoming more perfect and something becoming less perfect. When I just looked up more of a description than anything else about slowly improving as you have your descendants. It says that this process where beneficial genetic traits are passed from parent to offspring through the mechanism of inheritance, blah, 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 naturally occurred through evolution and selection process. So again, it's bringing evolution into this idea that something is slowly becoming more perfect. And so I believe in evolution theory in that's how we got from a single cell organism to a more complex cell organism. But the problem I have is with that idea of there being a perfect thing that we're trying to achieve or that nature is trying to achieve. That's the one idea that I don't. And so it gives me pause to say evolution just because it means to evolve something. But even that, we're changing the definition to get rid of that whole perfect, which is fine. It doesn't bother me to use the word evolution if we're not going to include any kind of ideal that's we're trying to achieve. When we're talking about different levels of the food chain or the food pyramid, not the nutrition pyramid of meat, cheese, blah blah, but the food pyramid like predator, prey, grazers, the microorganisms on that kind of a pyramid. And each one of those levels of, prey and predator now is, I think I've been calling it a troposphere, which doesn't make any sense because it's not a sphere. It's, usually represented as a pyramid or a triangle. So it is just trophic. It's trophic level. So that just, for my own sake, I really need to get that into my own head. because we do talk about this here and there. A lot of subjects are going to lead back to it because, the potential end of the planet and what that looks like, it's going to affect the animals. And so talking about that isn't just, and then the animals died. I mean, you could say that, and depending on the period of time, you could be right. But what we're looking at we're looking for the signs, right? We're looking to say, oh, this is happening. This is a sign of this collapse. There's a degradation in the food web here, and we're seeing this whole system might start to collapse here. So we're looking for those signs. So it's important to look at things individually, and even up to the trophic level of where we're taking out an apex predator and bumping everything up. So it's important to remember, again, for my own little brain, trophic, not troposphere. And yes, I know the troposphere is part of the atmosphere, and that's why my brain was A, remembering it, but B, confused when I said, I'm like, wait a minute, but that's part of the atmosphere. How's it both? That doesn't make, because it's not. Same prefix, but, and I'm sure it probably means layer. I don't know that for a fact, but we are talking about a trophy. The troposphere is a layer of the atmosphere, and trophic means a layer of, there's predator, there's prey, and each one goes on a different level, and so each one of those is a trophic level. But I don't know what to call the whole thing other than web, food web, but a web isn't a pyramid. And it's not food chain because a chain also isn't a pyramid. So you know what I mean? It's a little confusing. It's my own ignorance in that one. It's not. This has nothing to do with anybody having things wrong or me trying to correct things or anything like that. That's just my own ignorant brain not having a complete, understanding of the entire topic. But again, the whole point is for me to, know the word trophic. Right. So we have here producers and consumers, decomposers. So yeah, there's different words there, but none of them really give me a word for the whole, whatever they want to call moving up or down the ladders of the pyramid, because even there they're dividing that pyramid itself into two pieces. So a couple little subjects. This is the 19th of January. So when you're listening to this in like March, I think, or April, whenever it is this comes out, know that this is talking about January, and it's been like a few weeks now at least that this is the LA fires is what we're talking about. That I thought, oh well, we've got to have this under control by now, right? So I just looked up an update. So let's just get some of this information, on here. Not for the purpose of it being an update, obviously, because, like I said, this isn't going to come out till it's long gone. Which is sad because by that time we might have even forgotten. I mean, the people of LA will not have forgotten, but the rest of the world at large may have forgotten. And we not specific to LA, like we don't want to forget the LA, like we don't want to forget any of this stuff, right? Forgetting it is what makes it so that we continue to move on with our lives and not make any significant changes to try to better our planet. But so, list the three major fires. I don't know if any others are still going, or no, because the last one. Never mind. The last one is others. So everything else is under others. So two major fires and then others. So we got the Palisades, which is 52% contained. I mean, that's still better than nothing, but still, that's not 100%. And Eaton Fire is 81% contained, which is really good. And other fires, the Hearst, it says Otto, is that a fire? The Otto fire, I guess, and Little Mountain, all 100% contained. So that's good. So mostly it's the Palisades, which is still, 50% is good, but that means that's, almost half of the fire is still in no containment whatsoever. And strong, damaging Santa Ana winds are expected to bring extreme wildfire danger to Southern California Monday into Tuesday. So that's the holiday. This is the New York Times, by the way. We'll get a much better look at what the damage here is, because the news isn't reporting this at all anymore. It's an old story. They're bored with it. They're done. They're moving on. right? The big story now is the transition of power to the new president. That's the big story now. But still, I mean, if we can keep this in our own brain long enough, we can look back. And obviously, the longer out that we go, we can look back and hopefully people are doing some reporting, some sort of summarizing of things, looking back on it and getting all the information instead of now where the information is still coming out. So that was just something that I thought we definitely should touch on because obviously it is another one of those signposts of, things to come. And the fact that it is still going on even now is just insane that a big major city, the second most populous city is it? Or maybe third. No. Actually, I think it's one, right? The first most populous city, LA. I'm thinking of San Diego for some reason. I think it's like LA, then San Francisco, then San Diego, I think. Or it used to be. I'm not sure if it is anymore. Sacramento's in there somewhere, I'm sure. But yeah, so I think LA had the largest population. And so, short of dropping a nuke on LA, this is pretty huge, right? As far as just damaging this big city. And then I saw the news reporting that Malibu beach houses were on fire. And that's kind of like getting to some of the elite of the elite. They're saying, or somebody was saying, and this was a few days ago, so who knows what's changed since then, that the Beverly Hills homes were still perfectly fine. Like all the really, really rich people are not really in any kind of danger. Although obviously some celebrities' homes have burned. But what we're seeing is now some of the really rich people are getting their homes affected. I mean, there were some big homes in the fire, but mostly it's been a lot of poor people because their houses are closer together. They haven't got as many security and precautionary measures in. They don't have landscaping crews that come in and maintain. So it's always going to be a lot more dangerous for those neighborhoods than the richer ones. So to me, when you see some of these richer ones getting affected, it's like it's bad enough that even the favors and the money that they put in to try to get their stuff more so protected than anybody else, both inherently through maintenance, but also through, hey, get all the firefighters over here. I don't want my house burned down. Favors with the like government and stuff. Even that's not protecting, and that really, I think, says something. So the other thing was I was looking up. What I was trying to look up, and I couldn't really find this, but I found an interesting article to talk a little bit about instead, is I wanted to know what our percentage of ice on the planet is, comparatively speaking, from any other year. Like, are we getting a significant amount of the ice back that we're supposed to? Even if the summer comes and more of it melts than usual and we still end up with a smaller amount, the amount that we can refreeze is also an important. If the ice is coming back pretty strong, but then we're just melting more of it, it's still going to be really bad. But the ice isn't coming back as strong, maybe it's coming back weaker and weaker, then it's going to be easier and easier to get it all melted up. Because when it melts during the summer, we're supposed to refreeze it in the winter, and then of course we just melt more of it next summer. But if we're not even getting it back in the winter, then the melting damage doesn't even have to be as strong to really do the damage in the summer, because there's less stuff there to even have to do damage to. And not that I am not sure that one or two of those things are happening, but it's the extent that I'm interested in, the actual numbers. Like, if it says we've only got 20% of our normal annual, ice formed at this point in the year, even just in compared to the last 5 years, for example, if they said something like that, I'd be like, wow, that's really terrible. Something like that. So I couldn't find those statistics. I'm sure they exist somewhere. I don't know how to look for them specifically. I don't know where, but what I did find was it says NASA on the thing, but it's NSIDC. So I don't know what that is, but it has some charts and stuff, and it says sea ice data is updated daily with a 1 day lag. The number's going up, so I don't know what that means as the months. Well, I guess because it's starting in October, it would go up because it's freezing. So this is kind of what I was looking for. So there's a bit of a range in a sort of a gray, blobby area. There's a little dotted line that represents 2012 and 2013, which is below that. So the ice is coming back less there. And there's 24 to 2025, which is the winter we're in now, and it's less. Like compared to the top of the interquartal range and the interdactyl range, because it's just like a smudge up there. That's fine. But the point is at the top of the list and where we are, because it looks like we actually started in October with more ice than the 2012 2013. I mean, that's pretty good, right? But then we immediately go below that line and have stayed there, and we're not like dipping way down below it. So we're getting less back, it looks like, but not a huge amount less compared to then, which is good. I mean, that's definitely good news. On to our main topic. So the magnetosphere, the magnetic field lines that are all around the planet. In fact, let me look this up. I just heard Candace Owens on this. No, obviously, well, it's not obvious. I mean, you guys have no idea, but I wasn't watching her clip specific. I was watching somebody, and they played Candace Owens' clip. And she was talking about I think it was Gutsick Gibbon. And she was, no, it was on that's right. I don't remember whose it was, but it was a podcast that had Professor Dave Explains and Gutsick Gibbon on it, which is different because I don't usually see them together on a thing. It was pretty cool, so I definitely watched it with those guys. And it had somebody named Aaron Raw, and the dude's smart, but he's not really the type of person I would watch, as a podcast. He's not all that entertaining to me, but he definitely knows what the hell he's talking about. You know what I mean? Like there's no doubt about that. But they were all on there, and then they played that because I remember other people commenting things. And she was talking about the Van Allen belt, these high levels of radiation, and I was thinking, wait a minute, I that sounds familiar. And I believe the Van Allen belt has to do with the magnetosphere and trapping charged solar particles within the magnetic field lines of the Earth, and that's exactly what it is. So I just wanted to rewatch that because I just heard that thing and her trying to say that it's so hot that it would melt metal if it went through there. From what they were saying, and this isn't something that I would have known off the top of my head. I mean, I know that space is a partial vacuum, so there isn't much out there. But what I didn't really think about was there isn't a medium out there, so the heat out there isn't necessarily transferring directly to the materials. It can't radiate. You can't radiate that heat as well if you don't have a medium that has the energy hitting another medium and transferring that energy. And because you don't have that, you don't have a direct heat transfer in the way you would if something on Earth was that hot. So, again, that's not something I would have known or thought about, so that was interesting to hear. But it was just something that stuck in my head, and I wanted to look it up because we were talking about the Earth's magnetosphere. So I wanted to look that up real quick and get that information in my head. So we'll learn a few things here. But just wanted to start with, that's the magnetic field that's expanded beyond the Earth's bounds that protects us from the solar radiation. Because plasma, which is what comes off of the sun, is one of the, how should I say, it's what properties, that's the word I'm looking for. One of the properties of plasma is it reacts to a magnetic field. You have your solid, liquid, and gas, and everybody knows that. But we also have plasma. It's a different form of matter. One of the properties of plasma is it is affected by a magnetic field. Not that other ones aren't, but this is a property of plasma. And so when the plasma hits the Earth's magnetic field, it is going to be affected by it, and it's going to run along the Van Allen belt, right? The lines around the Earth, held there with the magnetosphere, which is generated by the Earth's core. Because how do you run an electromagnet, right? You wrap a copper wire around like a tube or something like that, and then you put a magnet in the middle and you spin the magnet, right? And when the magnet spins, it creates a magnetic field, and then that magnetic field creates the electrical magnetic action in the copper wires. They don't have to be copper, but it's just an example. And then the energy will flow through those wires, and that's essentially the basics of how we get electricity. And so that's basically what's happening in the Earth's core. Is we have, it's not just copper, like I said, we have a lot of iron and other magnetically receptive metals in the molten core, in the magma. The outer core, I believe, is what they technically call it. And then we believe the inner core of the Earth is a solid. And so you have this solid, mainly iron nickel ball that is magnetically charged. I mean, especially because it's a spinning piece of metal, right? So you're constantly aligning those particles in there. And so you have a spinning magnet inside of a large conductive material, and that is creating an electromagnetic field, right? And so that's why we get the magnetosphere, essentially. As to why it keeps moving, we have convection currents because that's how heat and thermodynamics work, right? The hot air rises, cold air sinks, and as you get that, you get a circular motion, right? One's going up, another is going down. Usually not directly on top of each other because they will displace each other. So usually one's like on the left, the other's on the right. I'm not saying those sides are specific. I'm picking those arbitrarily, but just as a visual example, the heavier, and the Coriolis effect affects, this direction. But yeah, you'll get it rising up on one side and then falling on the other because of the Coriolis effect. It's not just dropping in on its own self. And so you get this sort of circular loop pattern, and that's a convection current. And so that's happening, but with liquid rock in the magma, right, in the center of the Earth, because it is a liquid. It's not a solid there. The inner core is solid, but the outer core is not, and the magma isn't solid, even if it's a rock, and it's it's viscous, but not very. Like you're still moving rock, right? Even if it's liquid hot rock, you're still moving rock. So it doesn't move with like any kind of real speed, but it does move, and you do have a current where it gets hot from the inner core, and a lot of it is friction pressure heat, right? And it rises up where there's less pressure, less friction heat, and cools as it gets near the crust, and then back down to the core, because of course once it gets cool, it sinks because of A, gravity, but B, buoyancy. So you get these effects going within the inner core, and you get a convection current, and that's why we get plate tectonics and a lot of other stuff that makes life work on this planet. But that's just a general overview of the magnetosphere and why it exists. Now we're going to get into some specific stuff about it, and more importantly what the future is, but there is some stuff also about the past that could help inform the future. So all right, so here's something definitely not to panic about. Earth's magnetic field is rapidly Really hate that they say rapidly because it just really injects some fear here. Getting weaker. And geophysicists don't know why. So just right there, right off the bat, just as scary as hell, right? What the hell are you talking about? There's a lot more information. Some of it's reassuring, some of it not so much. But just pointing out that, and this is from science.org, that's a little bit of just a leading couple of sentences meant to invoke some panic. I think maybe to, induce the need to read the rest of the article to find out how effed we are, right? So I understand the psychology. I still think it's, kind of clickbaity, if you will. So obviously clickbait is to click on and read the article in the first place, not just look at the title. But this is, a type of clickbait where they want you to read the rest of the article and not just the headline. So it functions similarly. The decrease in strength is startling 10% in the last 160 years. But keep in mind, that's not like last year, right? When we talk about climate change, we talk about the change happened last year. Sometimes the last 10 years. But 160 years is still, it's a decent amount of time. Don't get me wrong, that's a huge decrease. And we're talking 160 years. 10% over every 160 years, and that's assuming it's a linear graph, is still terrifying. But, they're saying rapidly. 160 years isn't rapid for anybody. Nobody lives to 160. Nobody's ever lived to 260. Doesn't mean nobody could live to 160, but I think I saw somebody saying that the outer limits we're looking at are like 150, that if everything went perfect with you, every point in your life, no matter what, healthiest, blah, 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 you still wouldn't live past 150. It's interesting. I don't agree because we have genetic engineering now and ways to alter things now, even after you've been born, to change some of these parameters that they're talking about. But I also know that we don't have all the technology set up to affect those in the way we need to yet to extend life. But either way, 160 is well past anybody's lifetime. So it's still quick, but it's not rapidly like, oh my gosh, it's the last 5 years or something. Since you started listening to that song, it's decreased another 10% or anything like that. Could signal that the magnetic field is starting one of its sporadic flip-flops. But even if it's just a temporary blip, Earth's atmosphere may sustain some damage. According to reports here, so in science.org, December at a meeting of the American Geophysical Union, geologists know that the field occasionally reverses. The north magnetic pole becomes the south and vice versa. Before and during the transition, the strength of the field plunges. Today, the dipole is weakening so quickly that it would vanish within 200 years if the current rate continues. Some scientists have wondered whether this is the early stage of a reversal because the field has been stable for an unusually long 780,000 years. But to put that into context here, we're also looking at, because I'd mentioned this several times before, the Earth is actually cooling. So even if everything is going great in there and the magnetosphere just stays until the Earth cools to the point where it can't anymore, which is, a couple billion years at the soonest, really, roughly, it's not going to be there forever, right? And so it's, so what it's saying is that it's been, and this is the same with like earthquakes and stuff like that. It's like, yes, but the Earth is not the Earth that it used to be. So when things happened at a specific rate before, the Earth was changing. And then that changed, and then it was a specific set after that. But then the Earth changed, and now it's a specific, and they're like, things are so overdue. And it's like, but the Earth is cooling. The atmosphere has changed. There's a lot of different things about our geologic makeup, chemistry of the Earth now, that some things will change as far as how often this will happen or how often that will happen. So they're saying this is unusual, but It may not be unusual anymore. So just keep that in mind as we go into, some actual terrifying stuff. It's clear that some processes in the core is actively destroying part of the dipole, says geophysicist Jeremy Bloxham of Harvard University. Most destruction is happening in one spot, the South Atlantic anomaly, a patch of reversed magnetic field lines that emerge into space near the southern parts of Africa and South America. Bloxham's simulations of circulation in the core show that such patches sometimes grow into planet-wide reversals. However, most of them peter out within a few centuries as the core restores to normal. So that's your silver lining, your good scenario, everybody. Most times, it's happened plenty of times in the past. It's not the first time it's ever happened. And usually when it happens, it just goes right back to normal. On occasion, it's a flip. It's not a disappearance, even though, like they said, it will go down, it'll damage the atmosphere. But it has damaged the atmosphere before because it's happened before. And we're still here, atmosphere is still here, so it's not Earth ending. Right? What we're talking about is just as far as the reversal goes and as far as just a little dip and then it comes back goes. So if it's just one of those things, no big. When it weakens and then reestablishes itself, it's called an excursion. About 10 times more common than full-fledged flip-flops. In the last 50,000 years, there were many times when the field strength was a lot lower than it is today, without reversing. Coe says, the dipole may be stumbling, but it's far from a collapse. Still meeting speakers noted that a weaker field leaves Earth vulnerable to high-energy particles from the sun and space. Most satellites may suffer damage as solar ions penetrate deeper into the planet's weakened magnetic shield. Computer models also suggest that if the dipole keeps dropping, blasts from protons from major solar storms could destroy up to 40% of Earth's ozone at high latitudes for months to years at a time. We all know that is a big no-no for life on planet Earth. We need that ozone. Because then we destroy the magnetosphere, which keeps those solar storms from just ravaging the planet. And then we kill the ozone, which keeps just ambient radiation, along with those solar storm radiation, from destroying the planet's surface. So, yeah, we don't want either of those things to happen and F up our planet. Okay, so this here is amp.cnn.com. So it's from CNN. So this is a little section of an article. It's uncovering the Earth's field near collapse. So the intensity of Earth's magnetic field is known to fluctuate over time. And crystals preserved in rock contain tiny magnetic particles that lock any record of the intensity of Earth's magnetic field. I believe, if I'm not mistaken, those rocks, though they could have easily have just said it, but I guess this is for idiots. I believe that's zircon. I believe is the oldest, least destroyable crystals that we have on the planet, essentially. And so those have been around for a really long time. It's how we date a lot of things that have happened on this planet. So, the first evidence of Earth's magnetic field weakening significantly during the period came in 2019 as a study of 565 million-year-old rocks in Quebec that suggested the field was 10 times weaker than today at that point. The latest study collated more geological evidence and indicated the magnetic field weakened dramatically with information contained in a 591 million-year-old rock from a site in southern Brazil, suggesting the field was 30 times weaker than today. The weak magnetic field hadn't always been that way. Okay, unlike now, blah, 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 blah. Over billions of years, that process, so it's talking about the process of the magnetosphere happening, has become less efficient. And by the time we get to the Edikaran, I guess, the field is on its last legs. It's almost collapsing. But then, fortunately for us, it got cool enough that the inner core started to generate strengthening the magnetic field. The emergence of the earliest complex life that would have wafted along the seafloor at this time is associated with the rise in oxygen levels. Some animals can survive at low oxygen, such as sponges and microscopic animals, but larger animals with more complex bodies need oxygen. New research suggests an alternative or complementary hypothesis involving an increased loss of hydrogen to space when the geomagnetic field was weak. Estimates on when the planet's inner core may have solidified. When iron first crystallized at the center of the planet, once ranged from 500 million to 2.5 billion years ago. Earth's magnetic field almost collapsed 591 million years ago, and this change, paradoxically, may have played a pivotal role in the blossoming of complex life, new research has found. And so that was them talking about the hydrogen being kicked out of the atmosphere and us getting a lot more oxygen in. But so there you go. About 591 million years ago, the magnetic field of the planet almost 100% completely collapsed. So that's kind of terrifying that almost happened, but it's been, it's been going for, millions of years since then. So that's good. Okay, so this is talking about what would happen if Earth's magnetic field disappeared tomorrow. A large number of charged particles would bombard the planet, putting power grids and satellites on the fritz, increasing human exposure to higher levels of cancer-causing ultraviolet radiation. A missing magnetic field would have consequences that would be problematic but not necessarily apocalyptic, at least in the short term. Which is interesting because every other thing I've seen said no magnetic sphere means we're all going to die. But there's other problems with it that would mean it wouldn't even matter if we could survive with a weakened or missing magnetosphere as far as just the radiation hitting us, like we all lived in underground bunkers or something. That's not the real problem with that. The first thing to understand about the magnetic field is even if it weakens, it's not going to disappear, at least not for billions of years. So I don't know when this was written as far as the science they know, but we know that an article came out not that long ago studying the rocks and crystals inside the Earth and noting that their conductivity was, I think it was 0.5 times higher than they thought. And that as a result, the Earth is actually radiating the energy from the core quicker than we had thought. And so the new estimates, because I don't know what the old ones were, are that the Earth will cool and the magnetosphere will completely stop in like 1.75 billion years to 3 billion, somewhere in that range. Obviously, it's a big range, but until we get closer to it, we won't know enough to be able to get exact anyways. So I don't know if by billions it means like 1 to 2 billion, but technically more than 1 billion, right? Or if they mean a lot longer because it's the old time scale, which again, I don't even know what that was. So the churning outer core is powered by the convection of the heat released as the inner core grows and solidifies. Inner core grows by about 1 millimeter a year, which is not that significant. I mean, it's not insignificant either, but it's not largely significant, 1 millimeter a year for a core in the center of a giant planet. A magnetic field engine known as a dynamo has been chugging along for billions of years. This says, scientists think that the current core alignment may have settled into place around 1.5 billion years ago and found a leap of magnetic strength around then, and found evidence for a magnetic field on Earth's planet oldest minerals, zircon. So this one's actually calling them out, dating back to 4.2. So this isn't even mentioning that weakness that happened like 597 million years ago. So, but yeah, so it's the whole point of that was it's definitely saying if the magnetic field were to just disappear, that it would be bad. But that's not even a realistic thing anyway. So during a pole reversal, the magnetic field weakens, but it doesn't completely disappear. The magnetosphere, together with Earth's atmosphere, continually protects Earth from cosmetic rays and charged solar particles, though there may be a small amount of particulate radiation that makes it down to Earth's surface. In the past 200 years, Earth's magnetic field has weakened about 9% on the global average. Some people cite this as evidence a pole reversal is imminent, but scientists have no reason to believe so. In fact, paleomagnetic studies show the field is about as strong as it's been in the past 100,000 years, and is twice as intense as its million-year average. While some scientists estimate the field's strength might completely decay in about 1,300 years, the current weakening could stop at any time. So this again is talking about it weakening and then coming back, or weakening and then reversing. But that timeline, 1,300 years, is important. So, and I believe, will see that again. But yeah, so that is basically a kind of a worst case scenario. During the last major excursion, remember that's what they call it when the magnetic sphere kind of weakens and then comes back, called the last Champs event, radiocarbon evidence shows that about 41,500 years ago, the magnetic field weakened significantly. They don't say what significantly means, which is not helpful, and the poles reversed, only to flip back again about 500 years later. Now let's remember that 41,500 years ago, hominids were a thing. And obviously 500 years later after that, they were definitely a thing, right? And this didn't wipe out hominids and get rid of all complex life on the planet. So, we survived that. There is no evidence that the Earth's climate has been significantly impacted by the last 3 magnetic field excursions, nor by any excursion event within at least the last 2.8 million years. So that was the important thing to me, is that the 1,300 years. This is on science.nasa.gov. I think the last one was on NASA too. I forgot to look. Developing on a planet, blah, blah, blah. Star about 1 million miles per hour. Development of a habitable planet. Compared to Mars, a planet that lost its magnetosphere about 4.2 billion years ago. The solar wind is thought to have stripped away most of Mars's atmosphere. And we'll look a little bit more about Mars and what happened in the last article we're going to look at. Possibly after the red planet's magnetic field disappeared, this left Mars as a stark, barren world we see today through the eyes of NASA orbiters and rovers. Okay, if there were no magnetic field, we might have a very different atmosphere, left without life as we know it. The Earth's magnetic sphere absorbs the incoming energy from the solar wind and explosively releases that energy in the form of geomagnetic storms and substorms. How does this happen? Magnetic lines force coverage and reconfigure, resulting in magnetic energy and charged particles flying off at intense speeds. Scientists have been trying to learn why this crisscrossing of magnetic field lines, called the magnetic reconnection, triggers such a violent explosion, opening rifts into the magnetosphere. Lots of holes in our magnetosphere from time to time, I guess. You don't want to get hit by an X-flare during that. This is daily.jstor.org. So, and this is talking about Mars and how it lost its atmosphere, which is the more dangerous part of losing our magnetosphere. Billions of years ago, the atmosphere of Mars may have been denser and the air slightly warmer. Today, the ocean is just a memory. Billions of years ago, Mars lost its magnetic field. Without the protection that magnetic field offered, the atmosphere was stripped, and eventually the oceans evaporated as water vapor in the atmosphere was lost to space. Our life-giving sun can also take life away. The sun produces enormous amounts of radiation that, were it not for the protective effect of our magnetic field, would fry our planet. Without the magnetic field, the solar wind would strip our atmosphere, and the oceans would evaporate and be lost to space. In other words, Earth would end up like Mars. Earth is the only one of the rocky planets in our solar system to have a strong magnetic field. Its presence is likely one of the major reasons why Mars and Earth are so vastly different. But billions of years ago, Mars too had a strong magnetic field. Sulfur is probably in the core, since Mars meteorites do not contain many elements typically found alongside sulfur. Hydrogen may be plentiful in the core, since Mars is close to the quote-unquote snow line in our solar system, where water ice was abundant during planet formation. We can reasonably assume that the core is iron, sulfur, and hydrogen liquid, but needs to be verified by further Marsquake observations. Simulating high temperatures or pressures. The material separated into two distinct liquids, one with iron and sulfur, the other with iron and hydrogen. Because the liquid containing hydrogen was less dense, it rose to the top. And as the liquid separated, convective currents formed. Okay, as soon as the two liquids fully separated, the currents would stop, and the magnetic field would vanish. Eventually, the atmosphere would be stripped, and the oceans disappear. The temperature of the Earth's core is 6,740 degrees Fahrenheit, much higher than that of Mars's core. At these high temperatures, the iron, sulfur, and iron hydrogen liquids mix together. However, we do not see stratification higher in the core, where the temperatures are lower. This is the reason why Earth's core is stratified only at its top, while Mars's core is extremely stratified. It was saying that if the magnetosphere was to go away, or at least significantly weaken, that we're looking at around 200 years left of having an atmosphere like it all. Not breathable, livable atmosphere. Like just completely wiped off and gone for any... Like Mars has an atmosphere. The Mars atmosphere has very low density, as opposed to us, but that doesn't mean we couldn't end up with a low density atmosphere too. But we cannot breathe on Mars. Even if that low density was 100% oxygen, which we already learned would be a bad thing anyways, but let's just say that's 100% oxygen. The amount of oxygen we're taking in was enough to satisfy the oxygen component and didn't overwhelm us because there's so little atmosphere anyways, it still wouldn't be enough. If the Mars atmosphere was 100% oxygen, it still would not be enough for us to breathe there. So it's not just the makeup of the atmosphere, which I believe is mostly carbon dioxide on Mars. Even if we end up with that, although keep in mind we're also closer to the sun, so we would probably have even less atmosphere left than Mars does. I don't know how much longer Mars will have any atmosphere at all. Maybe it's just slowly going away and will someday be gone, and we just happen to see it at this particular stage in the atmosphere, disappearing. Some of it being there obviously has to do with gravity, but it's different forces opposing each other, right? There's gravity holding it in, but then there's the solar winds pushing it off, and this whole dance. And again, the Earth is a lot closer to the sun, so we're going to have our atmosphere stripped off maybe even faster than Mars did, and maybe even more completely. So either way, that means no life here on the planet. So no matter what we do to our atmosphere, good or bad, if the magnetosphere dips low enough, we're looking at 200 years before the atmosphere is gone. I do not know at what point life will not be able to be sustained on the planet, but I suspect it would be fairly quickly, especially if the ozone level is stripped off almost right away. No ozone level means no radiation protection, and unless you want to go the rest of your life in a spacesuit that not everybody has, and is extraordinarily expensive. It's not like you just go down to your local, St. Vincent de Paul and pick up a used spacesuit. Not everybody's going to have it. Even if we started manufacturing, as soon as we found out what was happening, we wouldn't be able to make enough for everybody. People are just going to die. Tons and tons of people are going to die. And to me, the scariest thing was the 1300 years. One number was saying that if the magnetosphere continues to weaken, that we're likely going to see it disappear in 1300 years. That was what a lot of scientists were saying. What they were also saying was, if it simply continues the way it has been, then that's only going to take 200 years. So one of them is, I don't know where to get the numbers for the 1300. I believe that the 200 is just extrapolation based on the percentage of what's happening and the time frame at which it's happened, and you extrapolate out and get 200. That makes sense, even though I guess they're looking at maybe an exponential, actually, for the two, because it's been 160 years, we only lost 10%. So another 200 years, we're only going to lose another 10% at that rate. So it'd have to be exponential at that point, wouldn't it, to be 200 years? That's something I would have to see a lot more evidence on to even believe that's really the way that it would work. I'm assuming that the 1300 years is closer to matching a linear graph as far as losing 10% over 160 years. So I don't know which is necessarily more true. Again, neither of these are in our lifetime, but the problem is it doesn't have to be 200 years before people die off. That's just the collapse. That's when it's gone. But as it weakens, our atmosphere is going to start taking a beating. And as that happens, life on planet is going to be a lot less hospitable. And we got to make it through that. And it gets more and more inhospitable. It doesn't then bounce back. So, unless we're talking about just a regular excursion, in which case it bounces back and no problem, we'll obviously still have problems. We need to regenerate all the ozone that we lost, like, last time when we depleted the ozone layer, right? And it is slowly coming back, which is great. So maybe we just have to be patient and wait and get that ozone level back. Maybe we could do some things to try to help out. All those things would be good. And survivable, right? That's not an apocalypse event. That's just real bad day on Earth. But losing the losing the magnetosphere is definitely an apocalypse event. One that I thought we weren't looking at for, somewhere around 2 to 3 billion years from now. But there is data that suggests possible, not probable, not necessarily even likely, but possible collapses a lot sooner, which, to be honest, those timelines still, if we went with climate change would still be the bigger threat because it will be more immediate. I suspect in the next 20 years, life on planet Earth is going to be not not all of planet Earth, because it would take a while to really make sure there's absolutely no place on planet Earth left where you would be just constantly in danger from the climate. But there will be huge portions of the planet which will basically be inhospitable due to the heat, right? In the next 20 years, I would think. Hopefully not. That would be great if it wasn't. But from what we're looking at, 20 years seems like it's going to start making some dead zones on our planet. But so 200 years out, that's way beyond where Earth wouldn't be able to support life anymore because we turned it into Venus. But barring that and saying we came up with some miracle technologies or something to save the planet, or just smartened up and save the planet that way, either way, I mean, we'll obviously still go through bad crap, but we could maybe eventually save the planet in totality. And then, a couple hundred years later, the Earth dies anyways due to a collapse of the magnetosphere. So, fun stuff to look forward to, I guess. So, yes, my opinion is that we need to start thinking about a world ship and colonization outside of our planet, and definitely outside of our solar system. And right now, the way things are going, with everything political and just everything, we will not be able to pull that together. World ship scenario and that kind of thing is something we will look at definitely another time, another podcast somewhere down the line. But right now, it's time to wrap this up. I got to get moving and head someplace to get some gas. So I'm all fueled up for my next adventure of work, which I'm excited about. I'm excited to have money again, to do the basics of life. Anyways, will we survive our own apocalypse? Only time will tell.